Section 3.2, Logarithmic Functions. Okay, before we start getting into the log functions, let's talk about who actually uses them. Biologists use them when they are studying the growth or decay of populations and making projections. Geologists, you may not know this, but the Richter scale is actually a logarithmic scale that geologists use. The pH scale is a logarithmic scale. When electrical engineers are working with electromagnetic strengths, they are working with logarithmic functions, as are chemical engineers when they are modeling fluid flows and the rates of reaction. So by the end of section 3.2, here are the objectives that you should have mastered. So let's talk about what a logarithmic function is. As long as x is greater than 0, b is greater than 0, and b isn't equal to 1, y equals log base b of x is the same thing as b to the y equals x. b to the y equals x. So here in example 1, we are given some logarithmic equations, and we're asked to rewrite them in exponential form. So just remember, if it's written in this form, log base b of x equals y, to rewrite it in exponential form, we would write it as b to the y power equals x. Okay, so let's get started. On example 1, 3 equals log base 7 of x. We rewrite that as 7 to the third power equals x. Okay, the equation 2 equals log base b of 25. That's b squared equals 25. And the last part of example 1, we've got log base 4 of 26 equals y. We would rewrite that as 4 to the y equals 26. And that's it for example 1.